The Aquifer Pipe Infiltration Bed, 100% fish exclusion solution plus. And you understand the plus by the end of this presentation. We started out 5 years ago taking this weird looking pipe and irrigating lawns with it, utilizing gray water. That's water that you use in your shower and your laundry, and then reapplying it subsurfacely under the lawn to keep it nice, lush, and green. What's interesting is that what's driving this marketplace is not so much the water conservation, but the ability to irrigate lawns and trees that keep the environment cool and thus the building cooler and save energy. We then moved into agriculture, taking that same pipe and burying it subsurfacely 5 feet below the ground and creating this moisture plume or virtual water table that the trees feed from. Once again, the driving economics is the energy savings by not having to pump as much water and being able to use power that is overgenerated by solar plants. They call this power solar curtailment or overcapacity. So we're experienced about moving water subsurfacely, and we're also experienced about finding other alternative stakeholders in the projects that we do. So when the fish price came along, we thought, hey, we can take this aquifer pipe, this weird looking pipe, flip it upside down, and be able to pull water out of a riverbed because we know how to push water into an area. And why we flipped it upside down is because as the water's coming through the gravel bed of a river bottom, if you put a round pipe, you're going to get direct connectivity of water coming through, kind of like a microsiphon. And by having the aquifer pipe upside down, then you're moving the whole bed as one unit. So you're diffusing the down well across the whole river bottom. We're new to the fish protection industry, so we asked a lot of questions, sat back and listened. And what we found by having this team assist us is that there's a lot of other issues out there. And so we started to dive in by talking to other stakeholders as well. And what came out of it was that fish exclusion or fish protection is usually aimed towards one species or one age group. And what was needed was something that was 100% aquatic exclusion, something that took care of current endangered species and future endangered species, from the eggs to the adults. And that's what our solution does. We solve a very complex problem by taking care of the whole aquatic life cycle. And not only that, we found that the food web was very important because you can save the fish, but if you don't save the food systems that they depend on, you're also shooting yourself in the foot. So our system protects a lot of that food web as well. The aquifer pipe is an off-the-shelf solution, meaning that you'll be able to go to your local plumbing supply and purchase it and to install it. Gone are the days where you have to have something custom made and then delivered to your facility. Plus the pricing could be sub $2,000 per CSF. And that's achievable the fact that the pipe itself is manufactured by a plastic extrusion as compared to a metal pipe that has to be custom built and custom welded and riveted. So it keeps the cost down very low. This is a very flexible system, meaning that it ranges as far as withdrawals anywhere from 10 gallons a minute to 10,000 CSF and can be applied for irrigation, drinking water, hydroelectric, pump storage, even an ocean withdrawal for desalination. So you have a lot of flexibility on the withdrawals and the application. And then the footprint can be custom designed to meet the contours of the stream or an area. So you have a lot of flexibility on how it's actually laid out in multiple areas. You can actually put it in the stream for the flow through, or it could be off stream during a restoration project. In this case, this particular photo shows what a 10,000 CSF design would look like. One of the items that kept on popping up when we asked a lot of questions was operations and maintenance. What's very unique about the aquifer pipe infiltration bed is that it has 0 moving parts. It's a passive system. So water flows down into the pipe, through the pipe, and exits out to the diversion canal. So that means that you have no trash buildup, no algae to clean up, No repairs after floods. You're not going to have logs or anything else stuck into the mechanism. And that's the key point. There is no mechanisms. There's no wear and tear on gears and chains or anything like that. For larger, complex jobs, use this big machine to put in the aquifer pipe. It has the capacity to put in about a 5,000 CSF infiltration bed in about 3 days. Everything is recorded as far as the depth, where the pipe is by GPS. So you're going to have a map exactly where the infiltration bed is and the positioning. For the smaller jobs, this excavator is what you use. One of the questions we get all the time is, what about biofilms and sediment buildup? Well, the pipe itself have enough flow through the pipe to scour the sediment and the biofilm. But like we've been down this path before, so we always have the skeptics say, well, it's not going to work. So here's how we would solve that problem if it does get clogged up. These are called hydrojets. And hydrojets can actually be pushed into the system from the shoreline, and it's a jet system that scours the inside of the pipe and is used for sewage systems. So that would solve the problem. Now remember, we asked a lot of questions, and what we found was that there was some forgotten knowledge. And this knowledge, no one actually had an infiltration bed design. And asking more questions, we actually found one that was installed 15 years ago in 2005. In talking to the general manager about the history of the infiltration bed, it was discovered that the first 8 years, there was no service done on it at all, even if the service recommended was to backflush it every 6 months. Well, this was great news because it showed that the infiltration bed actually performed with zero maintenance. That not only proved that this project was feasible, but it had resiliency. So going forward, we want to work on quantifying the results of this existing bed, showing exactly how much of the food web is being taken out, and do this research in detail with PNNL. Then move into installing an aquifer pipe infiltration bed and compare the difference between the two systems. I think we're going to show an improvement on the downwelling of flow and with a bunch of other features. And those other features are which really get us excited. That's where the plus comes in. I think we were going to be able to manage the stream flow regulation so we can always make sure that the stream has the minimum amount of flow through it without being drawn down too low. The ability to collect real-time stream flow data, height and flow, plus power generation from the flow through of the infiltration bed. And what we're really excited about is the dual purpose of the infiltration bed used as a habitat restoration and a water diversion. The habitat restoration meaning a spawning bed, a spawning grounds so that salmon can lay their eggs in the same infrastructure that we're withdrawing water from. That is awesome. What we're working on now is a revenue ROI. Now this is different than operation and maintenance ROI, where you get a payback because you have less maintenance and operation. A revenue ROI is how do you generate revenue from the infiltration bed by doing either power generation or selling the stream flow data to downstream resources that need it, such as dams or irrigation districts. But then what we really need help on, and we're going to ask the community, is how do we generate revenue from having spawning grounds or stream flow regulations? There has to be some way of capitalizing on those two infrastructure elements to help bring in additional revenue. Because the big idea is if you have revenue coming in for infiltration beds, then you're going to have an increase of installs. And what's really cool is that now we have this enhanced environment, stream flow diversion, and it's all being done in a holistic synergy method. Cool.